Bismillahirrahmanirrahim. Assalamualaikum class. Let's start the first part of our lecture 18. In the previous lecture, we have studied expected value and the variance of discrete random variable and the continuous probability distribution. We have seen that expected value of a discrete random variable denoted by E of x is equal to summation x into probability of x, whereas variance of discrete random variable is equal to expected value of x square minus expected value of x whole square. We can also write it as summation x square into probability of x minus summation x into probability of x whole square. This is the variance of discrete random variable. Continuous probability distribution. When a random variable is continuous, then its probability distribution is known as continuous probability distribution. In this lecture, we will study cumulative distribution function of continuous random variable and expected value and variance of continuous random variable. Cumulative distribution function. We have studied cumulative distribution function. We know that cumulative distribution function gives us sum of probability of x is less than equal to x. Therefore, we represent it by capital F of x. We studied in discrete case that f of x, capital F of x is equal to probability x is less than equal to x, which is equal to summation x is equal to 0 to x, probability x is equal to x. This is actually the general form of cumulative distribution function. When it is the case of discrete random variable, we use summation to sum up the probabilities. Now, here we are studying continuous random variable. So, what operator is used to sum the values of function at different points if the random variable is continuous? We use integration. So, the only difference comes here is we use integration instead of summation. Okay. Here we can see cumulative distribution function at any point x is equal to probability x is less than equal to that point. We say x. In discrete case, we take summation from the lower value to the desired value. Here we are using integration we will integrate our function, probability density function, from the lowest point to the desired point with respect to the variable. We have an example. Suppose that the error in the recreation temperature in degrees Celsius for a controlled laboratory experiment is a continuous random variable x having the probability density function f of x is equal to x square by 3 when x lies between -1 and 2 and 0 elsewhere. We have to find f of x, capital F of x, or we can say cumulative distribution function, and use it to evaluate probability x lies between 0 and -1. We have to calculate cumulative distribution function. We have seen what is cumulative distribution function. We integrate our density function from the lowest point to the desired point. When we have to find the general form of cumulative distribution function, we will integrate the function from its lowest value to the x. We will do the solution. F of x is equal to probability x is less than equal to x. This is the general form of cumulative distribution function. Now, how we can find probability x is less than equal to x? We will integrate our function, probability density function, on the limits. What is the lowest limit of our function? That is -1. So we will integrate it from -1 to x. That will be -1 to x. What is f of x? F of x is x square by 3, x square by 3 d of x x क्यूब by 3. हम पावर रूल अप्लाई करेंगे इंटीग्रेशन के लिए. -1 to x हमारे पास लिमिट्स आ जाएंगे जो कि हम इसमें पुट कर रहे हैं. So the function will be 1 by 9 x cube. और लिमिट हमारे पास क्या है? -1 to x. क्या रूल होता है हमारे पास? फर्स्ट वी विल put upper limit and then the lower limit. तो 1 by 9 as it is हमारे पास आ गया. 1 by 9 into upper limit क्या है हमारे पास? x. तो आ जाएगा x cube minus lower limit क्या है? -1. -1 raised to power 3. तो हमारे पास जो f of x आ गया cumulative distribution function, that is x cube plus 1 divided by 9. This is cumulative distribution function of our given experiment. Okay. Now, what else we have to do? Use it to evaluate probability x lies between 0 to -1. आपको लास्ट लेक्चर में भी बताया था मैंने कि when it is a continuous random variable, आपके पास अगर सिर्फ इनइक्वालिटी है तो इक्वालिटी हम इज्यूम कर लेते हैं। जैसे यहाँ पे हमने प्रोबेबिलिटी फाइंड करनी है, जो उसने लिखा है दैट इज x इज ग्रेटर देन 0 एंड लेस देन इक्वल टू 1, बट वी कैन यूज इक्वालिटी हियर। हम यहाँ पे इक्वालिटी खुद से इज्यूम कर लेंगे। क्लियर है? अच्छा, अब प्रोबेबिलिटी x लाइज बिटवीन 0 to 1। अगर हम इसको अपने यूजुअल मेथड से, अगर वो हमें सिर्फ कहता कि फाइंड दिस प्रोबेबिलिटी, तो हम इसको सिंपली इंटीग्रेट करते हैं। जैसे हमने लास्ट लेक्चर में पढ़ा था, हमारे पास जो प्रोबेबिलिटी डेंसिटी फंक्शन था उसको हम इंटीग्रेट कर देते ऑन दीज लिमिट्स। 0 to 1 तक हम इसको इंटीग्रेट करते तो हमारे पास रिक्वायर्ड प्रोबेबिलिटी आ जाएगी। ठीक है, एक इसका ये तरीका है हमारे पास सॉल्व करने का। दूसरा, उसने हमें यहाँ पे स्पेसिफाई किया है कि फाइंड cumulative distribution function and use it to evaluate this। और इसको, इस cumulative distribution function को हमने यूज करना है टू evaluate this probability। तो ये हमारे पास कैसे आ जाएगा? This will be probability x lies between 0 and 1 is equal to f of 1 minus f of 0। Okay, now how we will get f of 1? हमारे पास ये f of x है, x की जगह जब हम 1 पुट करेंगे तो हमारे पास cumulative distribution at x is equal to 1 आ जाएगा। जब हम 0 पुट करेंगे तो हमारे पास cumulative distribution function at x is equal to 0 आ जाएगा। तो ये हमारे पास क्या वैल्यू होगी? 1 plus 1 2/9 माइनस 0 पुट करेंगे तो क्या आ जाएगा? 1/9। Probability will be 1/9। Okay, we can calculate it by direct method or by using cumulative distribution function. Now we will see the graph of cumulative distribution function. This is a graph of cumulative distribution function of a given example। ये चीज हमने डिस्क्रीट में भी डिस्कस की। मैंने आपको बताया कि f of x when x is less than minimum value less than x1, f of x is equal to 0 when x is less than x1। and what is x1? x1 is the minimum value of the random variable, lower bound, and f of x is equal to 1 when x is equal to xn। and what is xn? xn is the uppermost value of the random variable। वहां पे जाके हमारे पास फंक्शन क्या हो जाता है? उसकी वैल्यू 1 हो जाती है और उसके बाद वो इंक्रीज नहीं करती। अब आप देखिए, हमारे पास इस क्वेश्चन में जो प्रोबेबिलिटी डेंसिटी फंक्शन था, मिनिमम वैल्यू हमारे पास क्या थी रैंडम वेरिएबल की? -1। मैक्सिमम वैल्यू क्या थी? 2। जब हम वैल्यू -1 से बिलो लेंगे x की, तो हमारे पास जो कम्युलेटिव डिस्ट्रीब्यूशन फंक्शन है वो एग्जिस्ट नहीं करेगा, दैट विल बी 0। इसके बाद उसकी कोई वैल्यू एग्जिस्ट नहीं करेगी। दिस इज द मिनिमम पॉइंट। इसी तरह जब वो अपनी मैक्सिमम पॉइंट लिमिट पे चला गया 2 पे, उसके बाद वो इंक्रीज नहीं कर रहा, वो 2 ही रहेगा चाहे कोई भी वैल्यू हो जाए। ठीक है, क्लियर है ये चीज? दिस इज ऑल फॉर दिस पार्ट। थैंक यू।